All right, we're going to be continuing on with our normal model and all of the things associated with that. Now, let's remember where we had left off yesterday or in our last notes. Where we had left off was a really important idea where we were comparing the location, that relative position of two different groups together on the normal model. So, like for example, in this case here, if you remember, we were comparing the first quiz, how well the student did on the first quiz relative to the other students, and then who took the first quiz, and then how they did on how well was done on the second quiz. And we determined that on the first quiz, the student scored 1.5 standard deviations above the mean. But on the second quiz, even though the score was 28, which is lower than 44, the student scored 1.67 standard deviations above the mean. So, relative to the average for the quiz, the student did better on the second quiz. So he was higher up in the class relative to how everybody else did. Okay. So it's that idea that we're going to expand upon today. So we had talked about how, well, you can't compare apples to oranges because they have those different weights. The apples are averaging 6 ounces, but the oranges are averaging 7.5. Well, with the normal model and with the Z scores, we can compare those two things. So here we go. All right. Again, last set of notes, we talked about this representation right here where we had done the normal model for the apples. So our normal model for the apples was a mean of 6 and a standard deviation of 1. And then our normal model for the oranges was a mean of 7.5 and a standard deviation of 1.5. So what we want to do is now discuss, okay, I have an apple that weighs 7.2 ounces. What percentile is that apple in? And I have an orange that weighs 9.3 ounces. What percentile is that orange in? Well, you may have heard of percentile before. Maybe your rank. Okay, what percentile are you in the class? Are you in the top quarter? Are you in the top 10%? Are you in the middle, 50%? What percentile are you in? Or even maybe when you went to the doctor growing up, what percent of heights are you in? They usually keep track of your heights and your weights as you're growing up and going to the pediatrician each year to see where you're following. Okay, so relative to all the others that are your age bracket, what percentile are you in? Okay, so therefore, by definition, percentile is that rank. That is that percentage of observations, the proportion of observations, the percentage of observations. Those mean the same thing. That falls at or below a particular score. A particular value, the percent that falls at that particular value or below it, that is your percentile. So if you're in the 90th percentile for height, 90% of the comparable group is shorter than you. Okay. If you're in the top 10% of your class, top 10% of your class, what percentile are you in? Well, that's the 90th percentile. Top 10% has 90% below you. Okay. So back to the apples and the oranges. So we have this picture here. And so here we have these apples where we've got the mean of 6 with a standard deviation of 1. So I've gone ahead and put the context in here. Remember, we're really focusing on also knowing our variables, that our context are those x values, and then our number of standard deviations are those z scores. Okay, so here is the orange So the context for the oranges and the z-score for the oranges. Here was our context for the apples and our z-scores for the apples. Okay, so then the question says, hey, what percentile is a apple that weighs, ooh, I hope I fixed this on your work. It's supposed to be 7.2 ounces. So we'll see if yours says 7.2 ounces if I fixed that typo. Okay, and so then there you go. So there is, I can tell based on this, that 7.2 is about right there. And then that area below is the percent. Remember, that was the very first thing that we learned was how the area below is the percentage. Okay, and likewise over here, 9.3. What percentile? Based on what area is below that location. So that's what we're going to learn how to do in our calculator. So if you do not have a graphing calculator, then that's something that you should consider getting, of course. Maybe your teacher has a class set of those. If you do not, we've talked about using an app for that on your phone. There's an app that you can get in the App Store. It's called Graph in Calc. I think it's Graph in Calc 83. So if you go to the App Store, if you have an Apple product, then you could do the Graphing Calc 83 and get that, and that would give you the graphing calculator on your phone. And it's like, I think it is $5, okay, which is much better than the $110 TI calculator, okay? If you have an Android phone, then I think there are ones that look just like the TI 84s, but it's the Apple products that you have to use the Graphing Calc 83. Okay. So let's go ahead and take a look at this. Here we go. So we're going to go ahead to our calculator and we're going to locate that. So look here on the calculator, which looks like this, we're going to find this normal model computing, and we want to compute with the accumulation of the area. See, down on our picture here, we want to accumulate this area below that calculator or that line, accumulating that area below. Okay, so that will be second, and then find the button that says vars. So here I have a calculator picture here. So here's the second, and then we have this vars right here next to the clear by the arrows, vars. And that's all the distributions, okay? So notice the first two. One of them says normal PDF. That's a particular value. We will never, ever, ever, ever use that. In a continuous function, that particular place is so teeny tiny that we're not interested in that. We need the accumulation of the area. So that's right here, number 2. So go down and click number 2. Now, if you have a menu that if you have an older operating system, then you have a menu that shows up. Okay, many of you may not, and the Graph and Calc 83 also does not have the Stats Wizard menu that shows up. So that's why I'm showing you this way first. Okay, so when this shows up, we will always then type in the lowest bound. So see right here, we will type in the lowest bound where we want to go to up to the highest bound of what we want to calculate. Okay, now if you happen to have the area of if you happen to have the updated operating system, then let me show you what yours looks like. Okay, so let me see here. So if we have this one here, then we're going normal CDF. See, look here. We have this lower bound And upper bound, so it's telling me it's a menu of items, lower bound, upper bound. The mean is 0, standard deviation 1. Always, always, always leave this mean as 0 and this standard deviation as 1, because we standardize it with a z-score, and so we're not going to use this feature of the mean and standard deviation on this menu. Now, if you're one of the other calculators, if you have one of the other calculators that doesn't have that menu, then you don't have to worry about it. Okay, so if you just naturally have got this situation here where you're going to go second vars, the normal CDF, okay, then you've got this. All right, let's take a look then at our notes. So what we want to do on our notes is we're using normal CDF, because that is always the cumulative area below where we're going. We will always use that, and because we are standardizing the curve. So here we go. Here's the problem about the apples. We have a mean of 6. In fact, let me come on over here and do this with you. Okay, so let me write this out with you. So we're going to come on over here and fill in our information. So we have got a mean of 6, a standard deviation of 1, because this was on the apples. And then the question was, I have an apple that weighs 7.2 ounces. What percentile is the apple in? Well, 7.2 is the context value. If we were to look at a picture over here, then here we have 6 and then, of course, 7, so filling in the context. And I'm going to have you do that because this is going to help you understand what's happening in this problem. Okay, and we are going to draw a line where we have our apple. Our apple is located at 7.2. Okay, so there's where our apple is, a context value of 7.2. All right, and then the question says, what percentile is the apple in? Well, shade that area. A percentile is the area below. So this is what we need to compute. All right, so that's how you work this problem. Now we're going to come on over here to the z-score. And do you remember from our last set of notes, to do the z-score, we're going to do our x minus the mean over the standard deviation. So in our case, this is 7.2 is x minus the mean over the standard deviation, x minus the mean over the standard deviation, and that is 1.2. So you can see that I drew my line 1.2 standard deviations above the mean. Okay, now to compute this area, we're going to do a norm CDF from the lower area up to the upper area. So let's talk about that. So what we're going to actually do is let's actually talk about the probability notation I want you to start learning. Okay, so we want to find what's the probability that I'm going to get a z-score less than 1.2. All right, that is the probability notation. Okay, now this next part you don't have to write, but I'm going to always write it. That probability notation is required. The next part isn't. So I'm going to put it in maybe gray, because you do not have to write this in. And that is finding that norm CDF. So we're going to calculate, put in that higher, norm CDF from a lower value to the upper value. Well, what would you consider the lower value here? I would consider this lower value all the way down to negative infinity. This is negative infinity way down here. And then the upper value, it's not 7.2. The upper value is that z-score, because it's the upper z-score, of 1.2. So our lower z-score needs to be negative infinity. Our upper z-score is 1.2. Well, the calculator doesn't have infinity, okay? So let's think about this. How many standard deviations is most data contained within? Well, 3 standard deviations down is pretty far. So if I was to go, there's 4 standard deviations down, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. If I was to go 99 standard deviations down, where is that? That's like forever, way far away, like at a different campus. It's not even at Aledo High School, okay? So we're always going to simulate infinity with 99. It's easy. It's the biggest number before you have to type in 3 digits. So 99. If we're simulating negative infinity, then we'll do negative 99. If we're simulating positive infinity, then we'll do positive 99. All right, so here we go. So we're going to do our normal CDF from low to high. So the lowest location that we're going is that negative 99. Okay, and then we go comma up to the highest point. And I want to go up to this z-score of 1.2. All right, so that's what I type into my calculator. And I have it in gray because you don't have to write it down. So here's how this looks. I'm going to go normal CDF from negative 99. And then the comma is above the 7. And then 1.2. And then I close the parentheses and I hit enter. And that's go to 4 decimal places. 0.8849. Now, if you had the other calculator that has the menu, so let me look at that real quick. So if you were one of the people who has this one right here, then I'm going to go negative 99, negative 99, up to 1.2 is the upper value. Leave this 0. Leave this 1. And then hit enter and paste it. And look, there it is, 0.8849. All right. So that is then that is what we're going to write. So that is 0.8849. Okay, we're going to always go to 4 decimal places, which then go ahead and tell me what percent is that. How do I turn decimal into percent? That is 88.49%. All right, that is what I'm looking for you. So what percentile then are you in? You are in the 88th percentile. Okay, because you haven't gotten to the 99th or 89th one yet. You are in the 88th percentile. All right, so that is how you do this problem. And this is the final answer work. Of course, you fill in all the other stuff. You fill in the other pictures. I kind of made a mess with it all. But there you go. Okay, let's do this next one. I have an apple that weighs 4.6 ounces. What percentile is the apple in? Okay, so same mean, 6. Standard deviation, 1. X, 4.6. Okay, now let's draw a picture over here. Here's 6, 5, 4. Okay, this is context. All right, draw your line. Draw where your apple is. My apple's at 4.6. My apple's about right there. Okay? Now, the question says, what percentile is the apple in? Percentile is area below. So this is then the area that I want to find the answer to. Now, just by looking at this, before I even compute, it says, why is the proportion of apples that weigh less than 4.6 ounces lower than 50%? Well, I hope you can tell that because here's the middle, the mean, and that makes up 50%. So obviously, this red area is less than 50%. Okay, but let's go compute. Where is our context located in terms of a z-score? I have to get the z-score to compute in the calculator. So my z equals x minus the mean over the standard deviation, x minus the mean over the standard deviation. And I'm just, I'm not very good at subtracting. So I'm thinking that that's like negative 1.4. So we're going to go with that. Yay, it is. Okay, so once we got that, so this z-score is negative 1.4. 1.4 standard deviations below the mean. So how do I get this area? I'm going down to negative infinity. So from least to greatest, I'm going from negative infinity up to 1.4. So let's do this. Here we go. Probability notation. Probability notation. Find the probability that the z is less than negative 1.4. Okay, that's the probability notation. And that equals. Okay, now I'm going to type this in here, but you don't have to. I'm going to do it in gray because it's not required. Norm CDF from the lowest part. Where was the lowest? Negative infinity, which I simulate with negative 99, comma, negative 1.4. Okay, and then that equals, and I'll do the answer. So let's go calculate that. Here we go. Second, vars, normal CDF, from negative 99 up to negative 1.4. Leave that 0 and 1, paste, and there we go, 0.080. Look at this 7. Don't you dare put 7 down. That 5 turns that 7 into an 8. Come on, you can pay attention to the details and get the rounding correct. So that is 0.0808. So that here is 0.0808 because it rounded, which if you do that in percent, that is going to be your 8.08%. Okay, so then, but it does say what percentile, so that's going to be the 8th percentile because you haven't gotten up to be in the 9th percentile yet. You're located in that 8th percentile. Okay, so there you go. All right, so let me let you try this one right here on your own. Go ahead and pause and see how you can do on that one. Go. Oh, this one's orange. Yeah, ooh, this one's orange. So what is that doing? If it's orange, we now have a different mean and a different standard deviation. Okay, so let's remember that. The mean is 7.5. The standard deviation is 1.5. And we want to know if the orange weighs 9.3 or less. Okay. All right, so 9.3 is a little bit above 9. So let's do my x minus the mean. So my 9.3 minus the 7.5 over the standard deviation. X minus the mean over the standard deviation. And interestingly enough, I think that z-score is 1.2, just like we had on problem A. So the z-score is 1.2. So then, here I go. Here is what I'm going to put. Probability notation. Don't forget that. Probability that the z-score is less than 1.2 equals. Okay. Now I'm going to do it in gray because you don't have to write this down. Norm CDF from negative infinity up to 1.2. And you know what? we already calculated that. It was 0.8849. So I'm just going to leave it at that. So 88.49%, which is in the 88th percentile. 88th percentile. Okay, done there. All right, so that is what's going on with finding that percentile, the lower area. Okay, but what do you think we need to do? In fact, you know what? I think I'm going to stop the video right there because we've been going long enough and I've been talking long enough. But what I want you to do is I want you to ponder and think about, what do you think would happen if I need to go above a particular point? What if I need to go from an apple that weighs 8.2 and then I need to go the area above? How do you think I could compute this? So I want you to do some math here, and then I'll come on to the next video and we'll see how you did. All right, good luck to you.